excited and honored to work with the Saudi Youth Space Association to take you all on an interesting journey about one of the interesting topics and thrilling observations about our sun, which are sunspots. Today is the second day of the Sunspots Virtual Bootcamp. Last Friday, we introduced you to sunspots and their relation to the solar magnetic activity. Today, we will teach you how to calculate and predict sunspots positions so you can do it yourself. Before learning how to calculate sunspots positions, we need to recap some of the information that were mentioned in our previous session and consider more information. So why do sunspots appear darker than the rest of the sun's surface? Well, sunspots appear darker because they're about 2000 Celsius degrees cooler than the rest of the sun's surface, where the temperature is about 4000 Celsius degrees and the sun's surface is about 6000 Celsius degrees. These temperatures are very high compared to the temperatures we have here on Earth or on any other planet in the solar system. And sunspots are basically cooler than the rest of the surface because of the various concentrations of flux in the sun's strong magnetic activity. What is surprising about sunspots is that though they have big sizes, they can last on the sun's surface from very, very few hours to several months.
Okay, now I want you to bring your calculators to calculate together the change in sunspot position. First, we will look to the horizontal line to see the difference in degrees between each sunspot position in 3 days from June 23 to June 26. If we want to calculate the difference, we should calculate the final position of the sunspot minus the initial position. So let's start with sunspot A. The initial position of sunspot A is around minus 45 degrees, and the final position, or after 3 days, it's around minus 12 degrees. So I want you to put in your calculators minus 12 minus 45. Or let's say, in other words, you can put minus 12 plus 45, and I want anyone to open their mics and tell me what you get as an answer.
33.
Okay, 33. Thank you. And we said from the beginning that the difference between them actually is 3 days. So I want you to divide this answer by 3, and I want you to give me the number.
11.
Exactly, 11. Thank you. So let's calculate many sunspot positions to find the exact number or the approximate change in all sunspot positions. Let's also calculate for B. B actually is beyond 60 degrees. So let's say it's approximately minus 70 degrees. And the final position of B after 3 days is minus 30. So I want you to calculate minus 30 minus 70. And again, I want you to give me the answer. By the way, I can't see the chat, so if you can just open your mic and
40.
Tell me. It's 40. And can you divide it by 3? Exactly, it's 13 point something, right? So you see different numbers, which means that we need to do more calculations for many sunspots to see the general number between them, or the average. So let's see in the next slide. Sorry. In the next slide, we will calculate the position of sunspot C. But the difference here is that the difference between the two pictures is 4 days, not only 3 days. So in sunspot C, the initial position actually is approximately minus 15 degrees, and the final position is around, let's say, 35 because it's between 30 and 45. So let's say it's 35. So I want you to put in your calculators 35 minus 15. Anyone got the answer?
50.
It's 50. And we said that the difference between these two pictures is 4 days. So can you divide 50 over 4?
12 and a half.
12 and a half. So we have now three numbers, 11, 13.33, and 12.5. The approximate number or the average between them is about 12 degrees. So what we can conclude about this?
What can be concluded from what Ilaf has mentioned is that sunspots seem to be moving at about 12 degrees per day. And with this information, we are ready to answer the big question. How long does it seem to take the sun to make a full rotation of about 360 degrees? Well, the Earth is moving around the sun in the same direction at about 1 degree per day, almost 365 days to circle the sun in a year. We need to add 1 degree per day to the apparent movement to allow for this. Where the movement the Earth makes, it seems like if the sun is rotating about less than it really is. The full rotation of the sun, which is equal to 360 degrees, will be divided by the sunspot's movement degree per day, plus the movement of the Earth's and the sun's same direction. The resulting number is 27. This basically represents the sun rotation on its axis once every 27 days. This shows how important and useful studying sunspots is.
Actually, the activity we did and the calculations you did by yourselves is a simple explanation about the way that scientists used for many years before to calculate the sunspot positions and the sunspot appearance. In the first diagram, actually, it's called the butterfly diagram because it actually record or measure the appearance of the sunspots for 20 years, from 1880 to 2000. In the second diagram, it's a diagram to calculate the area of the sunspots for the same 20 years. And if you can see in the second diagram, actually the shape of the graph is similar in each year or each 11 year. And this is actually the times that sun takes to have a full rotate. And now feel free to ask any question you have.
Do you have any questions to ask about what has been mentioned throughout the session?
No, but I have something off topic a bit.
It's fine.
May
We will
I
try.
ask?
Yes.
So if someone like misses one of these sessions, does he still get the certificate or no?
Our requirement is that you attend all 3 sessions, but if you accidentally miss one session, and you can contact us and we will send you a recording. And if you watch the recording and if you can summarize a bit of what was discussed, you will still get the certificate.
Oh, okay. Thank you.
Any other questions?
If you don't have any questions, so thank you so much for attending. We enjoyed today's lesson and we hope you enjoyed it as well.
Yeah, our session
Thank
today
you.
has came to an end. I hope you all enjoyed it and found it useful. Thank you very much for attending and for your attention throughout the whole session. Looking forward to meeting you again on the last day of the Sunspots virtual bootcamp on Tuesday at 7 p.m. Goodbye and have a good night.
And if you didn't, and please remember to put your name and email in the chat if you didn't do so at the beginning of the lesson.